Hi, I'm Jonathan Hall. It's the last day of No Effort November, so this is my last video in the series. And today I'm going to talk about how to read a stack trace. If you've been using Go for more than about, 15 minutes, you've probably run into something that looks a little bit like this. And if you're new to Go, it probably makes about as much sense as this.
Ad klaxon ris blajblanarnik karnik.
So how can you cut through this pile of crap and make sense of what's going on here? I'm going to break it down for you and make it as easy to read as something that's easy to read. I don't know. Let's get started. Let's start with a really simple example. I've created a program that all it does is panic. Let's run this program, and it'll have a really, really simple stack trace, but that's a good starting point for learning how to read it. So the first thing you're going to see at the top of a panic stack trace anyway is the word panic, and then a description of what panicked. It could be an error string. It could be a runtime error. In this case, because I called panic myself, it just outputs the text that I told panic to panic with. Oh no. That's not really the confusing part, of course. What starts to confuse people is the stack trace. Now, because this is a very simple program that only has a single function and a single line in that function, the stack trace is very short, but that's what this is. And so let's talk about the component parts. So the first line here tells me the name of the package and the function and its arguments that panic. In this case, it's the main package, and within that package is the main function, and it has no argument. That's straightforward enough. What's usually a little more valuable from a debugging standpoint is the next line, which shows us the source file name and the line number where the panic occurred. So if I open up that file, I can examine where the panic occurred. Here's main.go, line 4, and that's exactly where I would have expected this to have occurred. So that's an example of the simplest stack trace. Let's look at a little bit more complicated one that's a little more likely to be representative of something you see in the wild.
Let's see what's out there.
So this stack trace is from one of my open source libraries, and it happened when I ran the tests recently. So if I scroll up just a little bit here, we can see that I was running the tests, and a particular test failed. This isn't really part of the stack trace, but the context is relevant for debugging, right? And here's that first line, the panic line. And it tells me I have a runtime error, invalid memory address, or nil pointer dereference. You're likely to see this all the time. So now this is a lot more confusing than main.main that we saw in the previous example, right? Here we have testing.trunner.func1.2 and then some random numbers. What this is telling us is basically that the testing package itself, which is part of the standard library, is where the panic originated. Now, this is an anonymous function, basically, or a closure. We don't care about those details. What you want to do when you see a stack trace like this that has a lot of details you probably don't care about, you want to read down past the first entry. You want to find one that references your code. So unless you're debugging the standard library, this line is not relevant to you. Nor is this line. This is also part of standard library. Now here, panic. So that's the built-in panic method. That's also not relevant. Here we go. Here's the first line that references my code. So this is my package, github.com/gokivik, kivik v4, blah, blah, blah. And here's the function that was being called, get. When I called this get method on this db type, that's when the panic occurred. The next line is the one that is almost certainly the most relevant in 99% of cases. And this is the one that tells me which file had the panic and on which line. So fsdb/get.go, line 36. Let's pull that up. Here's the relevant file, get.go, line 36. So this is the line that panicked. Can you tell from reading this line what panicked? Why we have a nil pointer dereference? Well, there's two likely possibilities. Either options is nil or ops is nil. Now I can see here the ops is not nil because I just set it to something. So options must be nil for some reason. However, this doesn't really help me debug it very much. So let's go back to that stack trace again. Let's go down one level. So this is the line I was just looking at. Let's go to the next one. Here we can see another reference to my code. This time it's the test-get function. And we can see that this happened on get_test.go line 401. So let's pull that up. So here's that line. So and here we're passing in that argument that over here we decided is almost certainly nil, right? So here's the options argument. It's the last argument to this method. Here we're calling the method, and ops must be nil. So now we can see where the panic is occurring. Something needs to happen to make sure that this ops is not nil. So that's very quickly how you can use a stack trace to pinpoint where the bug is happening in your program. And then, of course, it's up to you to decide how to solve that problem. So what are all these other random numbers and symbols in the stack trace?
173467321 Charlie 32789777
Well, in general, you can just ignore them. These 0xC000 blah blah blah. Those happen to be memory addresses that point to variables that are being passed around. For certain advanced debugging techniques that can be useful, I virtually always ignore those. The thing you are going to most care about is the path to the code that panicked and the line number. And if you look at one of those cases and it doesn't make sense, go to the next level, and eventually you should be able to find where the bug in your code is happening. I hope this has been helpful. I hope you've enjoyed my No Effort November series. If you're new here, be sure to hit subscribe. And if you learned something today, hit the like button. I hope to see you next time for a longer, little bit more effortful video. Until then, make it go.